This is an audio-visual presentation on trigonometry. Trigonometry is the study of relationship between the length of sides and angles of a triangle and other figures. Now we consider a right-angled triangle. Considering the right-angled triangle below, theta is an acute angle. An acute angle is an angle greater than 0 degrees but less than 90 degrees. Now this right-angled triangle has three sides. When we consider the acute angle theta, the side BC is opposite to the angle theta. The side that is opposite to the 90 degrees angle is the longest side, and that is called the hypotenuse. And the third side, AB or BA, is the adjacent to the angle theta. So we have the three sides. We have the opposite to the angle theta. We have the longest side, that is the hypotenuse, and we have the adjacent. This triangle ABC is a right-angled triangle, and a right-angled triangle is a triangle that has one of its angles being equal to 90 degrees. And the side that is opposite to the 90 degrees angle is the longest side of the right-angled triangle, and that is what we call the hypotenuse, that is H. So from the right-angled triangle ABC, the adjacent side is A. The opposite side to the angle theta equals B, and the hypotenuse, that is the longest side of the triangle, is equal to H. Now we have the sine, the cosine, and tangent of angles. Sine is equal to SO. That is the opposite side over the longest side, that is the hypotenuse. So sine of an angle is equal to SO, the opposite over the hypotenuse of the triangle. So sine is equal to SO, that is opposite over hypotenuse. Cosine of an angle is equal to K. That is adjacent over hypotenuse. So the adjacent of the triangle, considering the angle theta over the hypotenuse. Now, tangent of an angle is equal to TOA. That is opposite over adjacent. So we have opposite over adjacent. So the SO is opposite over hypotenuse. The K, that is the cos, is adjacent over hypotenuse. And the tangent, that is TOA, is opposite over adjacent. So we have SO, K, TOA. Now let's consider the right angle triangle. ABC is a right angle triangle, and theta is our acute angle. Now the side BC is opposite to the angle theta, and the side AC, that is the longest side of the triangle, that is what we call the hypotenuse. Now, sine of the angle theta, sine is equal to SO, that is opposite over hypotenuse. Now, when you consider the angle theta, the opposite side is BC, that is B. And the hypotenuse is the longest side, that is H. So, sine of the angle theta is equal to SO, that is opposite over hypotenuse. And the opposite side to the angle theta is B, divided by the hypotenuse, that is the longest side, and that is H. And so sine theta is equal to B over H. Now, cos of the angle theta, cos is equal to K, that is adjacent over hypotenuse. Now, when you consider the right angle triangle ABC, considering the angle theta, that is the acute angle, A is adjacent to the angle theta, H is the hypotenuse. So if cos theta is equal to K, then it means that it is adjacent over hypotenuse, and the adjacent is A, and the hypotenuse is H. So cos theta is equal to A over H. Similarly, tan theta, that is tan of the angle theta, tan is equal to TOA, that is opposite over adjacent. Opposite over adjacent. Now, when we look at the right angle triangle, we have ABC. Side AB, that is A, is adjacent to the angle theta. BC is opposite to the angle theta, and H, that is AC, is the hypotenuse of the right angle triangle. Now if tan theta is equal to 12, then the opposite side, the opposite to the angle theta is B, and the adjacent to the angle theta is A. So tan theta is equal to 12. That is opposite B over adjacent A. Now example. Find the value of theta in each of the following figures. We have the figure in A and the figure in B. Now when we consider the figure in A, we can see that we are given two sides of the triangle, and we are left with the third side to calculate. Now we also have the acute angle in the triangle. We can see that side 4, this side with length 4, is opposite to the angle theta, and 3 is adjacent. Now when we consider the diagram in B, considering the position of the acute angle, the side with length 15 is the longest side of the right angle triangle, and so it means that we are given the hypotenuse to be 15. Now the side 13 is opposite to the angle theta. That means that we know the opposite side and we know the longest side, that is the hypotenuse. Now let's look at how best we can solve all these problems, the problems we have in A and B. Now solution. Considering the right angle triangle in A, theta is an acute angle. The side 4 given is opposite to the angle theta, and 3 is adjacent. That means that if you consider this right angle triangle, we have our adjacent side and we have our opposite side. Now the opposite is equal to 4 because that is the side that is opposite to the angle theta, and the adjacent is equal to 3 because that is the side adjacent to the angle theta. Now we are given the opposite to be 4 and we have our adjacent to be 3. So how do we find the angle theta? We need to use the ratio tan theta because tan is the same as 12. Tan is equal to 12, and 12 means opposite over adjacent. That is opposite over adjacent. Now we are given the opposite side and we also know the adjacent side, and therefore we use tan theta. Now tan theta is equal to, the opposite side is 4 divided by the adjacent, and the adjacent is 3. Now when we divide 4 by 3, the answer is 1.3333. If we have tan theta is equal to 1.3333 and we want to solve for theta, that is the angle, we need to take the tan inverse of both sides. So theta on the left hand side will now be equal to tan inverse of 1.3333, and the answer is 53.1 degrees. The answer is 53.1 degrees. Now let's look at the solution to the diagram in B. Considering this right angle triangle, looking at the position of the acute angle, the side with the length 15 is the longest side of the right angle triangle, and the side 13 is opposite to the angle theta. That means that we know the opposite side and we know the hypotenuse. Now the opposite side is 13. That is opposite to the angle theta, and the longest side, that is the hypotenuse, is 15. So we know the opposite side to be 13 and we know the hypotenuse to be 15. Now sine is equal to so, and so is opposite over hypotenuse. So we use sine of the angle theta. We use the ratio sine because we know the opposite side and we know the hypotenuse, and therefore sine theta is equal to 13 over 15. Where 13 is the opposite side and 15 is the longest side, that is the hypotenuse. 13 divided by 15 is equal to 0.8667. Now here we are also finding the acute angle theta. So theta will be the tan inverse of the answer on the right hand side. If you have sine theta is equal to 0.8667 and you want to find theta, you need to take the tan inverse of both sides so that you can only have theta on the left hand side. So theta is equal to the sine inverse of 0.8667, and this is equal to 60.1 degrees. Now let's consider the diagram as shown. We have the x-axis and we have the y-axis. Now in trigonometry, angles measure rotation in the anti-clockwise direction from the positive x-axis. In trigonometry, positive angles measure rotation in the anti-clockwise direction from the positive x-axis. I repeat, in trigonometry, positive angles measure rotation in the anti-clockwise direction from the positive x-axis. So we have 0 degrees, we have 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees. And 360 degrees makes one complete revolution. That is, we start from the positive x-axis till we get back to the same positive x-axis. It's one complete revolution, and that is 360 degrees. Now, we have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, looking at the first quadrant, we have all. Sine is positive, cos is positive, and tan is positive. What do we mean by this? This means that between 0 degrees and 90 degrees, the sine, cos, and tan of any angle will give you a positive answer. That is the meaning of all. So sine, cos, and tan of any angle between 0 degrees and 90 degrees will give you a positive answer. Now, when we go to the second quadrant, sine is positive, cos is negative, and tan is negative. This means that between 90 degrees and 180 degrees, it is only sine of an angle that can give you a positive answer. The rest will give you a negative answer. So it is only sine that is positive in this quadrant. Now, when we go to the third quadrant, we have term. That means only tan is positive. Sine is negative and cos is negative. That is, when you take the sine and the cos of any angle between 180 degrees and 270 degrees, you will get a negative answer. But tan of an angle between 180 degrees and 270 degrees will give you a positive answer. Now, we are now in the fourth quadrant, and that is cut. That means that only cos is positive. So between 270 degrees and 360 degrees, when we take sine of any angle, the answer is negative. When we take cos of any angle, the answer is positive. And when we take tan of any angle, the answer is negative. So we have all, silly, term, cut. All, silly, term, cut. All means all the ratios are positive in this quadrant. Silly means only sine is positive in the second quadrant. Term means only tan is positive in the third quadrant. And cut means only cos is positive in the fourth quadrant. Now, example. Given that sine A is equal to 5/13 and that A is acute angle, find cos A and tan A without using calculator. So we are given sine A to be equal to 5/13, where A is an acute angle, and you know that acute angle is an angle that is greater than 0 degrees but less than 90 degrees. We are asked to find cos A and tan A. Now let's see how best we can solve this problem. From the question, we were given sine A to be equal to 5/13. Now you know that sine is the same as so. And when we say so, we mean opposite over hypotenuse. That is SOH. So sine A equals opposite over hypotenuse. Now from the question, we were given sine A to be equal to 5/13. That means that the opposite side is 5 and the hypotenuse is 13. So opposite is equal to 5 and the hypotenuse is equal to 13. Now by the Pythagoras theorem, the square of the longest side is equal to the sum of the squares of the other two sides. And the longest side is 13. That is the hypotenuse. It is given in the question. We have 13 because sine A is equal to 5/13. So the hypotenuse equals 13. Now, this is our angle A. That's our acute angle. Opposite to the angle A is 5. That is why 5 is opposite. And the longest side is 13. Now from the Pythagoras theorem, the square of the longest side is equal to the sum of the squares of the other two sides. And the other two sides are the side with length 5 and A. Now we see how we can calculate for the A to get the 12 we have here. Now by Pythagoras theorem, 13 square, that is the longest side square, is equal to the sum of the squares of the other two sides, that is a and 5. So we have a square plus 5 square. Now 5 square will give us 25 and 13 square will give us 169. So plus 25 on the right hand side plus 25 on the right hand side becomes minus 25 on the left hand side. And so we have 169 minus 25 is equal to a square. This can also be written as a square is equal to 169 minus 25. That is, the right hand side now becomes the left hand side, and the left hand side now becomes the right hand side. It is the same thing. We have not changed the equation. Now remember that we are solving for the length a. And here we have a square equals 169 minus 25. So we have to take the square root of both sides so that we can do away with the exponent 2. And our a will now come out. Now a will be equal to the square. That is, when we take the square root of a square, we are left with a. And when we take the square root of 169 minus 25, you have the root of 169 minus 25. When you subtract 25 from 169, the answer is 144. So the square root of 144, this is equal to 12. Now we know that the adjacent is now 12. The opposite to the angle A is 5, and the hypotenuse is equal to 13. Now we have to find cos A, and we know that cos is the same as K, and K means adjacent over hypotenuse. So the adjacent side is 12 and the hypotenuse is 13. That is why cos A equals 12 over 13. Now with tan A, tan is the same as twa. That means opposite over adjacent. Now when you consider the acute angle A, opposite is 5 and the adjacent is 12. So tan A is equal to 5 over 12. Now let's consider the angle of elevation and depression. Suppose you stand at S and you are looking at an object above your level, that is above your height. The angle between the straight line drawn from your eye to the object you are looking at and the horizontal to your line is called the angle of elevation. I repeat, suppose you stand at S and you are looking at an object above your height. The angle between the line drawn from your eye to the object you are looking at and the horizontal to your eye, that is PR, is the angle theta. That is the angle of elevation. Now, PQR is now a right angle triangle with a 90 degrees angle at R. Theta is the angle of elevation. Now, when you consider the angle theta, from Q to R has been given to be A, and A is opposite to the angle theta. PR is adjacent to the angle theta. And so if you want to find the angle of elevation theta, tan theta will be equal to, you know that tan is the same as twa. That is opposite over adjacent. So when you consider the angle theta, the opposite side is A and the adjacent side is B. That means that tan theta is equal to A over B. Now, if you have tan theta is equal to A over B and you want to find the angle theta, take note that the angle theta is the angle of elevation. And so theta will be the tan inverse of the right hand side. That means that theta is equal to the tan inverse of A over B. And so when you take the tan inverse of A over B, the angle of elevation will now come out. Now, considering the diagram as shown, assuming you are standing on the block S and you are looking at an object at point B. In this case, the object you are looking at is below your eye level. The angle between the line drawn from your eye to the object you are looking at and the horizontal to your eye is what we call the angle of depression. So for the angle of depression, you look at objects below your eye level. But for the angle of elevation, it means you are looking at an object above your level. Now, the angle of depression is the angle between the line drawn from your eye to the object you are looking at below your level, your eye level, and the horizontal to your eye. So the angle is beta. So the angle of depression is beta. Now here you can also see that the side DB, that is C, is opposite to the angle beta, and the side AD, that is D, is adjacent to the angle beta. So if you want to find the angle beta, then we can say that tan beta is equal to opposite, that is C over D. And taking the tan inverse of both sides, beta is equal to tan inverse of C over D. And the angle of depression will now come out. Now let's look at this question. A vertical pole, PQ, is erected on a level ground. A man 2 meters tall stands at R, 30 meters away from the foot Q of the pole. The angle of elevation of the top of the pole, P, from the man is 60 degrees. Calculate correct to the nearest whole number the height of the pole. Now let's go over this question again. We have a vertical pole, PQ, is erected on the level ground. The pole is vertical, erected on a level ground. A man 2 meters tall, that is the height of the man, 2 meters tall, stands at R, 30 meters away from the foot Q of the pole. So the distance from where the man stands to the foot of the pole is 30 meters from the question. Now, the angle of elevation of the top of the pole, of the top P of the pole from the man is 60 degrees. Calculate correct to the nearest whole number the height of the pole. Now let's look at how we can solve this problem. Now, considering this diagram, we are asked to find the height of the pole, and the pole is PQ. This is the top of the pole P, and Q is the foot of the pole on the ground. So we have PQ. Now, the height of the man is 2 meters. So RU is the height of the man. Now from the question, the distance from where the man stands at R to the vertical pole is 30 meters. That means from R to T, or from U to Q, is 30 meters. That's the distance from where the man stands to the vertical pole is 30 meters. Now, the man stands at R and he looks at the top of the vertical pole, P. The angle of elevation will be the angle between the straight line drawn from R to P and the horizontal level, horizontal to the eye level of the man, horizontal to the eye level of the man. So this angle is the angle of elevation. From the question, the angle of elevation is 60 degrees. Now we are solving for the distance from P to Q. Take note that RU is equal to TQ. That's the distance from R to U is equal to the distance from T to Q. So if RU is equal to 2 meters, then it means that from T to Q is also 2 meters. Now the height of the vertical pole is from P to Q. Now that we know TQ to be 2, if you are able to calculate for the distance from P to T, we can now add the distance from P to T to 2, and that will give us the height of the vertical pole. Now, triangle PTR is a right angle triangle. That is triangle PTR is a right angle triangle. This is a 90 degrees angle, and this is an acute angle. Now, we are searching for the length PT. When we get PT, we can add it to TQ because we know that TQ is equal to RU, that is 2. So we are now searching for the length PT. Now, PT is opposite to the angle 60 degrees and RT is adjacent. So if we are looking for the opposite side and we are giving the adjacent together with the angle, then it means that we use the ratio tan theta, that is tan 60 degrees, because tan is equal to 2, opposite over adjacent. And since we are searching for the opposite side and we are given the adjacent, we use the ratio tan. So tan 60 degrees is equal to opposite. The opposite side is PT. So PT divided by adjacent, and the adjacent is RT, and the distance from R to T is 30 meters. So we have PT divided by 30. Now, if tan 60 degrees is equal to PT divided by 30, how do we find PT? We have to cross multiply. So 30 multiplies tan 60 is equal to PT. Now, PT is equal to 30 tan 60 degrees. Tan 60 degrees is equal to 1.732. So when we multiply 1.732 by 30, the answer is 52 meters. That means that the distance from P to T is 52 meters. This means that the distance from P to T is equal to 52 meters. Now, the height of the pole now is equal to PT plus TQ. And PT, after calculation, we have 52. And TQ, that's the distance from T to Q, is equal to the distance from R to U, that is 2. So the height of the pole is equal to PT plus TQ. And that is 52 meters plus 2 meters. 52 meters plus 2 meters is equal to 54 meters. That means that the height of the vertical pole is equal to 54 meters. Now let's consider this example. A cliff is 206 meters high. The angle of depression from the top of the cliff of a boat is 30 degrees. Find the distance of the boat from the foot of the cliff to the nearest meter. A cliff is 206 high. That is the height of the cliff. The angle of depression from the top of the cliff of a boat is 30 degrees. Find the distance of the boat from the foot of the cliff to the nearest meter. Now let's consider the solution. We are given the height of the cliff to be 206. That's the distance from P to Q is 206. Now, from the top of the cliff, if we are looking at an object at R, then the angle of depression will be the angle between PR and the horizontal to your eye level, or horizontal to the top of the cliff. That will be the angle of depression. Now, from the question, the angle of depression is equal to 30 degrees. Because this line from P is parallel to line QR, and we know that alternate angles are equal, that means that the angle of depression is equal to the angle at R, that is 30 degrees. Now, when we consider triangle PQR with the angle 30 degrees, that's the acute angle. The side PQ, that is 206 meters, is opposite to the 30 degrees angle. And the distance from Q to R is the adjacent to the angle 30, and that is the distance we are searching for, from Q to R. So QR is question mark, but the opposite, that is PQ, is 206. Now, we are given the opposite, and we are calculating for the adjacent. So opposite over adjacent, we have to use the ratio tan, that is 2, in order to calculate for the adjacent side, that is QR. So tan 30 degrees is equal to 206 divided by QR. That is tan 30 degrees is equal to opposite, that is 206, divided by the adjacent, that is QR. And that is how come we have tan 30 degrees is equal to 206 divided by QR. Now we are solving for QR, so we have to make QR the subject. So after cross multiplication and dividing through by tan 30 degrees, we have QR is equal to 206 divided by tan 30 degrees. I'll give this to you as an exercise, that from tan 30 degrees equals 206 divided by QR. Make QR the subject and see whether you will get QR equals 206 divided by tan 30 degrees. Now, tan 30 degrees is equal to 0.577. So 206 divided by 0.577 is equal to 357 meters. Is equal to 357 meters. That is the distance from Q to R. Now let's consider this example. Two given points S and T, which are at opposite sides of a tower, are 20 meters apart. S, T, and the foot of the tower are in the same straight line. The angle of elevation of the top of the tower from S and T are 32 degrees and 42 degrees respectively. Find, correct to 1 decimal place, the height of the tower. Now let's analyze this question. Two given points S and T, which are at opposite sides of a tower. So if S is on the left hand side, then it means that T is on the right hand side of the tower. Now they are 20 meters apart. That is the distance from S and T is 20 meters. S, T, and the foot of the tower are in the same straight line. The angle of elevation from the top of the tower from S and T are 32 and 42 respectively. This means that the angle of elevation of the top of the tower from S is 32 and from T is 42 degrees. Now we are asked to find, correct to 1 decimal place, the height of the tower. The height of the tower. Now, considering the diagram, AB is the height of the tower. That is the distance from A to B. AB is the tower. So from A to B is the distance. That is the height of the tower. We are given the distance from S to T to be 20 meters. And the angle of elevation from S of the top of the tower is 32. That is the angle of elevation. And the angle of elevation from T of the top of the tower is 45 degrees. Now from the question, S and T are on opposite sides. That is why S is on the left hand side of the tower AB and T is on the right hand side of the tower AB. Now let's see how best we can find the height. From triangle SAB, and where do we have our triangle SAB? We have triangle SAB. AB is the height. 32 degrees is the acute angle. Take note that SAB is a right angle triangle. So we can see that the height H is opposite to the angle 32 degrees. And the side SB, that's the distance from SB, is adjacent to the angle 32 degrees. And so tan 32 degrees, tan means twa, that is opposite over adjacent. So the opposite side is H and the adjacent side is the distance from S to B. So from triangle SAB, tan 32 degrees is equal to opposite, that is the height of the tower, divided by adjacent, that is SB. Now we are asked to find the height, and that is H. And so we try to make H the subject by cross multiplying. So SB multiplies tan 32 degrees. Take note that tan 32 degrees is the same as tan 32 divided by 1. But tan 32 divided by 1 is the same as tan 32. That is why the 1 cannot be seen. So by cross multiplication, when we multiply H by the 1, we have H. And this is equal to, we now multiply SB by tan 32. So we have H is equal to SB tan 32. Now, making SB the subject, we divide the right hand side by tan 32. And we also divide the left hand side by tan 32. And in doing that, we have SB on the left hand side equals H divided by tan 32 degrees. Now, tan 32 degrees is equal to 0.6249. 0.6249. This means that the distance from S to B is equal to H over 0.6249. Now, coefficient of the h here is 1. When we divide 1 by 0.6249, the answer is 1.6003h because of the h. That means that the distance SB is equal to 1.6003h. Now, from triangle ABT, and where is our triangle ABT? This is our triangle ABT. Considering this triangle, H is opposite to the angle 45, and the distance from B to T is adjacent. So it means that tan 45 degrees is equal to H over BT. So tan 45 degrees is equal to H divided by BT. Now, making BT the subject, we have BT is equal to H divided by tan 45 degrees. Now, tan 45 degrees is equal to 1. And now, instead of H over tan 45, because tan 45 is equal to 1, we have H over 1. And H divided by 1 is equal to H. Now, let's go to the diagram and see what is happening here. ST is equal to SB plus BT, and this is equal to 20. We were given the distance from S to T to be 20 meters. The distance from S to T was given to be 20 meters. Now we've calculated for the distance from S to B. We have calculated the distance from S to D, and we have also calculated the distance from B to T. So when we add the distance from S to B and the distance from B to T together, it must be equal to 20 meters. And so the distance SB gave us 1.6003h, and the distance BT has given us h, so we have plus h. So 1.6003h plus h is equal to 20. Now we can factor h out, and we have 1.6003 plus 1. Now when we add 1 to 1.6003, the answer is 2.6003. But because it's times h, that is why we have 2.6003h. Now 2.6003h is now equal to 20. That is the distance from S to T. And so if 2.6003h is equal to 20, how do we solve for h? We have to divide the left hand side by 2.6003, and we divide the right hand side by 2.6003. When we divide the left hand side by 2.6003, we are left with h. And when we divide 20 by 3, we have 20 divided by 2.6003. That is, we also divide the right hand side by the same 2.6003. And so when we divide 20 by 2.6003, the result is 7.7 meters. So the h is equal to 20 divided by 2.6003, and this is equal to 7.7 meters. That is the height of the vertical pole, 7.7 meters. This is the end of our presentation on trigonometry.